Hi, everyone. I would first like to thank you all for taking your time and for engaging in our work this year. We are a sub-team within the HSTEM Enterprise program focusing on prosthetic devices. So, who are we? As stated before, we are a sub-team of the HSTEM Enterprise, and we are a group of 14 members encompassing a wide variety of majors. These majors include biomedical, mechanical, electrical, and chemical engineering, and even material science majors. This diversity gives us a dynamic range of knowledge. We are also a very new team. The HSTEM enterprise itself was founded in the fall of 2021, and our team was initiated a year later in September 2022. We find ourselves fortunate to have a large range of interest, which has put our project off to the races. So now that you know a little bit about who we are, let's dive into what we actually do. So as mentioned earlier, our group focuses on prosthetic devices and more specifically below knee prosthetics. We are driven by the fact that annually 150,000 people undergo below knee amputations, and the most common cause of these amputations is diabetic ulcers. And with a rise in the diabetic population, these amputations seem to follow suit regarding the amount affected. Furthermore, recovery from this procedure is only made more troublesome to the patient through acquiring a prosthetic device. A few of the major challenges encountered upon receiving a prosthetic include extremely long manufacturing process times to account for the completely individualized components, high monetary cost, and often patients are not fully satisfied with the comfortability of their prosthetic due to the socket design and inadequate ventilation. Therefore, our goal as a team is to provide an innovative solution while minimizing these shortcomings. Our project is working to tackle these inefficiencies by designing a device that is fully functional for the patient and easily accessible regarding ease and cost of construction. To obtain this goal, we defined requirements that our device must follow, which include the use of modular components. The end result must be individually compatible, and the cost of manufacturing must be less than $1,500. These requirements have proven to be difficult to meet, but when upheld, will result in a device that will enable hundreds of thousands of individuals to regain their livelihood. So now, to dive into our plan to tackle this project, we have decided to split this project into three main components, which are the creation of a pressure mapping system, development of a representative CAD model, and finally, the design of a compatible prosthetic. Our first step is to create a pressure mapping system. This task will utilize pressure sensors to determine the pressure across the entirety of the stump. Information will then be translated into a graphical mapped image, which will indicate how much and where pressure is being applied. This graph will illustrate areas of both high and low pressures and allow physicians to see where potential issues may arise. Furthermore, while using this data, a representative CAD model will be produced mimicking the amputee's stump. While using this model, individualized components will then be developed to fit the exact dimensions of the stump, while also taking into consideration the individualized pressure areas. These components will then be produced and implemented into a pre-configured prosthetic. The pre-configured prosthetic will utilize modular components to configure the majority of the structure and encompass the individualized components to ensure patient compatibility. We started our project by doing a lot of background research. This research included extensive literature reviews and interviews with an amputee and physical therapist. We recognize that this does not provide us with enough clientele input and are actively seeking more opportunities to meet with potential clients. However, these opportunities and research have resulted in a few key determinations, which include the locations of pressure-sensitive areas around an amputee's stump, and that these areas must be accounted for when sensing pressure. The other major concept that we pulled from our research was that patient comfort is the most unaccounted for component when designing prosthetics. And with this in mind, we have made it our goal to make these determinations our priorities. While conducting background research, we started testing potential solutions. We knew that we wanted a quantitative measurement of the pressure seen across the stump. With this in mind, we started testing with strain gauges and pressure sensors. The measurements we got from this testing provided us with the conclusion that pressure sensors provide a much easier measurement to work with. Strain gauges provided us with valuable data regarding the differences observed during motion, however, it required extra calculations and more room for noise variability. Upon the determination that pressure sensors were more effective, we did further research to define some requirements that our sensors must uphold. Through this, we determined that our sensors must be compatible with up to 0.5 pound per square inch per pound of body weight. They must be flexible to account for mobility, and we need multiple sensors to provide adequate data. So that is what we did. Now, to give you an idea of what we are currently doing, right now we are working on developing the pressure sensor code. Our biggest struggles with this include interpreting multiple sensors and getting a graphical representation. To mitigate this, we have acquired multiplexers to increase efficiency. Another issue we have had is acquiring sensors, as the 20-kilogram sensors we wanted were on a production delay. This being said, we had to go with much smaller scale sensors to begin preliminary testing, which leads us to the characterization testing that we are also conducting. This testing is used to prove our concept as functional. We are working on producing a test method that meets our ideas, as well as the regulations defined by the FDA in CRF Title 21. These tasks have proved to be challenges, as unforeseen events have delayed our progress, but we have learned to adapt to continue progress. And finally, you all might be wondering where we are going with this project. As previously stated, our design plan includes 3 major parts: the pressure mapping system, a generation of a representative CAD model, and finally, a functional prosthetic. We are currently working to develop the pressure mapping system and intend on having it completed September 2023, which will then lead us into the generation of the individualized CAD model, which we hope to complete in December of 2023. This will then allow us to configure a functional prosthetic that is patient compatible and easily manufacturable by the end of the following school year. So with this in mind, we would like to thank our sponsors, the Enterprise Program, the Department of Kinesiology and Integrated Physiology, and the Department of Cognitive and Learning Sciences for all their support. We also want to take this opportunity to thank our wonderful advisors, Smitha Rao and Stephen Elmer, for their guidance and help on our project. Thank you.